A very good morning, good afternoon, and good evening to our lecturer, Puan Nohanisa Asrin binti Mohammed Mokhtar. Our title is Smart Traffic Light Control System. Before we start, let's introduce ourselves and our matrix card number.
Hi everyone, my name is Ng Guan Wei. My meeting number is 01DEM23F1003.
My name is Wei Zing Yu, and my matrix number is 01DEM23F1032. Introduction. Smart Traffic Light Control System (STLCS) is an embedded system designed to dynamically adjust signals timings based on real-time traffic demand. Next will be the system description. We are using core sensor inductive loop sensors. So the inductive loop sensors detects a vehicle by sensing a change in the electromagnetic field when a metal object passes over it. The signal is sent to a dedicated embedded control unit (ECU) to process the demand and after the traffic light sequence. These sensors-based systems have been in use since 1950s and are a standard component of modern adaptive traffic control systems (ATCS).
Hi everyone. For the function of the smart specific light, we use the inductive loop sensor we show in the diagram. So it is loop sensor are installed in between the loop surface. In Malaysia, it's like that ah. So when the vehicle stop over plus the loop, it distributes magnetic field generating a signal that signifies vehicle pressure or count. This data transmit as an input signal to the controller cabinet. Hi everyone. So now we're discussing the processing part. The signal is received by dedicated circuit board, often containing microcontroller MCU or high performance low power microprocessor like an ARM mesh chip or AVR32. If the sensor on the red light approach detect no vehicle, the system may skip the phase or shorten the minimum read time. If a continuous string vehicle is detected on the green light, the system may extend the green phase up to a program maximum. The traffic design like that is increase the efficiency of the traffic, reduce the traffic jam. So now we discuss the output. The MCU send a control signal to the relay or switch unit within the control cabinet. This unit control the electrical power flow into the LED signal, changing the light phase, example green to yellow, then red. So the reason why we use relay is to activate the high power because the signal for the microcontroller is low power. Hi everyone, this is the flow chart of the smart traffic light system. First, when the system start, initial system it will read the sensor of the traffic light, which is inductive loop sensor. So it will proceed the data. So check if the vehicle is got vehicle or not. So if not vehicle in the road, the all the traffic light is turned red for the safety. So it got the if the sensor detect the vehicle, the traffic light first, it decide the traffic light phase, which is set the traffic light which is green. So when the set turn to green, it will monitor the load sensor. It will detect how many car. So decide the time. Is need to extend the time for the green. So is yes switch to is no switch to the next phase. So that's all.
Next is the difference between previous and current technology. In previous technology, we use fixed time traffic controller, and for current technology, we use Smart Traffic Light Control System (STLCS). The underlying system for previous technology, which is fixed time traffic controller, is electromechanical simple timers, which is based on cams, dials, gears, and relays. But for the current technology, which is smart traffic light control system (STLCS), is real-time embedded system that based on a microcontroller and solid state components. For operation logic, for the previous technology, it is static and fixed. The cycle is constant and preset based on historical data. The red light remains on for the preset time even if the road is empty. But for our current technology, it is dynamic and adaptive. The signal timing adjusts continuously in response to actual real-time vehicle presence and volume detected by sensors. Next is the input. Fixed-time traffic controller relies on primary on an internal clock or timer. But for smart traffic light control systems, it relies on sensor. It uses inductive loops, IR, or radar to generate input. Last will be efficiency and benefit. Fixed time traffic controller causes unnecessary stops and idling during off-peak hours. But for the current technology, smart traffic light control system, it minimizes the waiting times, reduces congestion, and lowers fuel consumption and emissions by only granting green light when demand is on. Next is the embedded system characteristic. First characteristic is the real-time operation. It is a hard real-time requirement. Traffic control is safety critical, and the system must process sensor input and change the signal within a guaranteed strict time limit. A timing failure is not just an inconvenience but a safety hazard. Next will be specific functionality. The system is dedicated to one function, monitoring traffic demand and controlling the intersection signals. The microcontroller runs specialized firmware optimized solely for signal sequencing, sensor reading, and algorithm execution. Next will be resource constraint. The controller is designed for high reliability and durability to operate 24/7 in a non-climate control roadside cabinet. It uses low power hardware to conserve energy and manage the cost and size of the unit. Last will be fixed or programmable. It is highly programmable while the core hardware is fixed. The software logic algorithm like genetic algorithm or simple demand actuated logic is programmed into MCU's memory. This allows the system behavior to be updated or modified to adapt the new traffic pattern without replacing the entire physical unit.
In conclusion, the Smart Traffic Light Control System SDLCS which rely on physical sensor like inductive loop for real-time data is the robust and effective application of a hard real-time embedded system in modern infrastructure. Unlike its predecessor, the fixed-time controller, the SDLC set operated dynamically the system microcontroller MCU process sensor input immediately to execute complex optimization algorithm that ensuring that traffic light only changes on genuine demand. This adherence to real-time safety circuit deadline, especially for events like emergency vehicle prevention, classify the system as hard real-time. Furthermore, it dedicated hardware resource continuous design and programmability perfect among the core characteristic of embedded system. By efficiency management, the traffic flow, the SDLCS successfully achieved its goal of reducing vehicle waiting time, minimizing traffic congestion, and decreasing fuel consumption and associated carbon emission. Provide it to be super intelligent solution for urban mobility.
This is our reference. Thank you.